Okay, in this video, we are officially going to start talking about a calculus topic, and that is going to be in the form of limits. Okay, so this is in your textbook, and this will just kind of give you a preview of, what to expect at the beginning of first semester next year if you decide to enroll in Calc AB. Okay, so limits is a fairly simple concept, and we're going to start by answering this simple question here. Given f of x is equal to x squared minus 1 over x minus 1, the first question I asked is what is f of 1? And the second question I'm going to ask is what value does f of x go to as x approaches 1? Okay, so here in the notes, I wrote answer using a table, a graph, and algebraically. Okay, so one of the concepts, right, that you learn both in calculus, both in math analysis and eventually you'll learn in calculus if you decide to take it, is that you have to be able to do things three different ways, right? Using a table, using a graph, and using algebra. Okay, so let's answer this first question, right? What value does f of x go to as x approaches 1? Well, using a table, right, here's 1. And basically what I did was I plugged in some numbers to the left of 1, right? To the left of 1, 0.999, that's pretty close to 1, right? 0.99, not as close, 0.98, right? So really you want to think about it going this way. And same thing for to the right of 1, right? You can start with 1.1, get a little bit closer, 1.01, and then even really close, 1.001, right? I mean, you could even plug in 1.00001. All right, so if you have a calculator next to you, what you could do is you can plug in these x values into this function, right? And then figure out what those corresponding y values are, right? And if you kind of take a look, right, based on what my y values are, what value does f of x go to as x approaches 1, right? X is approaching 1 here from the left, x is approaching 1 here from the right, getting closer to 1. That number, right, that f of x, the y value gets close to, or go to, is 2, right? So f of x appears to approach, actually we could use the word approach as well, this number 2, right? Now, to answer this question, right, what is f of 1? Well, immediately, if I ask you what is the value of f of 1, right, 1 squared minus 1, well, that's 0. 0 divided by 0, you're going to have an undefined, right? This guy right here is undefined. Okay, so you don't know what the value of f of 1 is, right, because it's undefined. But I can say, what value does y approach, right? The y looks like it's getting closer to 2 if I approach, 1 from the left side. Y also looks like it's going closer to 2, right? This number 2, as x is approaching 1 from the right side. And so this first question, right, is basically an algebraic question, like evaluate what is f of 1. This second question, which seems kind of weird to some of you for the first time, is like, what value does f of x go to? Or you can use the word approach. As x approaches 1, right? X is approaching 1 from the left, x is approaching 1 from the right. The y value looks like it's getting closer to 2. And that is really a calculus question. And so the first time you of course, see it and hear it, it seems kind of weird, right? But it's not too bad, as you'll see in this lesson. Okay, so we answer this question using a table, right? It looks like the y value, or the f of x, is approaching 2 as x is approaching 1 from the left and x is approaching 1 from the right. And herein lies the definition of the limit, or informal definition. Okay, so we talked about approach, right? If f of x gets close to some number L, okay, so f of x, right, is your y value, gets close to some number L, as x approaches c from the left side and the right side, the limit of f of x as x approaches c is L. Okay, so let me kind of translate this jargon over here and write it as a symbol. So this is what your limit symbol is going to look like, right? The limit as x approaches c, okay, this arrow just means approach c, of f of x is equal to L. Okay, so this is your limit notation. And basically, how we translate this into this, right? Because x is approaching 1 in this case, right? The 1 is going to be our c. Our f of x is just our function, right? And we answered this question, right? If f of x gets close to some number L, that number L is basically 2. Okay? So the limit as x approaches 1, right? Approaching 1 from the left side and the right side, the limit of f of x as x approaches c is L, okay? So this is your limit notation. This means approach. This is your function. And this is the y value that f of x gets close to as x approaches c from the left side and the right side, okay? So I'm going to talk about this we're going to re-emphasize this in detail later on. Okay, so there's our informal definition of a limit. Remember, you have to approach x from the left side and the right side. And basically, you're trying to see what your y value is getting close to. In that case, our y value is 2, and that's the answer to calculating a particular limit, right? All right, now how do we do the same problem graphically? Well, when I always harp on you guys how important your algebra skills are, it's absolutely critical in calculus, and so you're going to have to know all your algebra skills back from semester 1 and semester 2 in both math 3 and math analysis. Okay, so graphically, how do I graph a function? Well, let's take a look at this graph, right? F of x is equal to x squared minus 1 over x minus 1. And this graph is simple enough that you don't need a scientific or graphing calculator, okay? All right, so this is basically a rational function. And the way you graph a rational function, right, is always simplify first. And so I'm going to simplify, right, if possible. Okay, now, what does simplifying do? So reviewing your rational function skills, right? If you're able to cancel something, which I am right here, that means there's going to be a hole at whatever I cancel my factor at, and I'm going to set it to 0 and solve for x, right? So the way I solve for a hole, right, is whatever I canceled, I set it equal to 0, right, and then solve for x, right? I cancel the factor of x minus 1, and the x value of the hole is located at 1. Well, going back to this original function, my f of x is now x plus 1, right? And to get the y value of the hole, right, remember the procedure, right? You plug in the x value of the hole into the simplified function, right? F of 1 in this case, we're not going to say f of 1. Well, I guess we can plug it in right here. F of 1 is equal to 1 plus 1, which is 2. All right, now, this f of 1 is not a true f of 1, right? We're going to say that there's a hole at 1, comma 2. Okay, so even though f of 1 is technically undefined right here, I guess I really shouldn't have written this. This might confuse you. Just recognize that there's a hole over here. Okay, so really, maybe I should just write 1 plus 1. You know, 1 plus 1 is equal to 2. Okay, I don't want you to think f of 1 is 2. There's a hole at 1, comma 2. Okay, so I am going to graph this function, and I know there's a hole at 1, comma 2. So let's graph it. So this is basically a line. Okay, so the x-intercept of this line right here is -1, right? The y-intercept is 1, and we have a hole at 1, comma 2. 1, comma 2. Right, and so if you take a straight edge, which I'm trying to do this really sloppily, there's my f of x. Okay, so there's my line, a hole at 1, comma 2, right? At And I'm going to try to answer this question again. What is the limit as x approaches 1 of f of x equals question mark? Okay, so the way you look at it from a graphical standpoint is, again, you don't care about what happens at the value of 1, right? This question, right, just to kind of reiterate our concept is, what is the y value? F of x is the y value. What is the y value approaching as x approaches 1 from the left side and from the right side, right? If you go back to the original definition or informal definition, right, y value gets close to some number L as x approaches C from the left and the right. Okay, so even though you don't see that, right, you kind of go back to the definition. So as x approaches 1 from the left, right, approaching 1, here's the value of 1. As x approaches 1 from the left, you can see, right, that the y value is getting closer to 2. But I also have to approach 1 from the right side. Okay, so you always have to go back to the definition. And later on, I'm going to define left-hand limit and right-hand limit. So as I'm approaching 1 from the right side, right, the y value is also, right, getting closer to 2. And so from the graph, you can see that the limit as x approaches 1 of f of x, right, as x approaches 1 from the left and the right, the y value is getting closer to 2. Again, we don't care about what happens at this number. We know that f of 1, right, f of 1 is still undefined, right? Again, there's a reason why I erased this, right? I'm just doing the calculation to get the y value of the whole. But you know it's undefined, and so you don't say the limit is f of x, limit of x approaches 1 of f of x is undefined. You say the limit as x approaches 1 of f of x is equal to 2 because this number L, right, is what f of x gets close to, okay? So again, that concept of we don't care about what happens at the value of 1, right? The value of 1 is undefined. F of 1 is undefined. But the limit as x approaches 1 of f of x is equal to 2, right? And this number is what the y value gets close to as x approaches 1 from the left and the right, okay? So it bears worth some time for me to explain this concept. And once you understand the concept, right, you can kind of see it's not that big of a deal interpreting limits both using a table and a graph. And then the very last technique is direct substitution, okay? So the limit as x approaches 1 of f of x, my f of x, right, is this function right here. How would I do this problem if I just did it algebraically? X squared minus 1 over x minus 1, right? And you're going to be doing problems like this in your homework. Well, again, you have to simplify, right? We already know that this cancels out, and it just basically becomes x plus 1, right? This function simplifies to this function. And you basically just plug in and substitute, right? 1 plus 1 is equal to 2. So that's using direct substitution. Okay? So you can see that's probably the easiest way to do this particular problem, but you're introduced to this concept of limits, and that's really all there is to it, okay? It's saying, what is the y value getting close to? All right, going back to my original notation here. When you see a problem like this, it's saying, what is the y value getting close to as x approaches C from the left side and the right side? And whatever that number is, right? In this case, our example, the answer was 2. So you can interpret a limit both using a table, right? Plugging in x values, see where the y value gets close to. We don't care what happens at 1 because at 1 it's undefined. And using a graph, okay? And a simple function like this, right? I expect you guys to be able to do by hand. Again, you can see that there's a hole at 1, 2, but we don't care about what happens at 1. Just close to 1. Close to 1, right? The y value is getting close to 2. Close to 1 going from the right side, the y value is still getting close to 2. And also direct substitution.